Today we're going to talk about multiplying with decimals. So we've done multiplication when it's all whole numbers, but today we're going to introduce decimals and what to do with those decimal points. So the first strategy I want you to try is estimation. Now, estimation will not get you your final answer, but it will help you figure out if your final answer is correct. And if you're looking at a multiple choice question, it might help you cross off or eliminate some answers before you even do your multiplication. So when we estimate, we want to round to the nearest whole number. So starting with my first factor, 2 1400ths. Now, is that closer to 2 wholes or to 3 wholes? Well, halfway would be 2 5/10. So I'm looking at my tenths place, 1/10, that's smaller, so I'm going to round down and call this approximately. That's what that wiggle means, not exactly, but around 2, times 3 7/10. Well, 7/10 is larger than halfway between 3 and 4, so I'm going to round that up to 4. So this is approximately 4. Again, this is not going to give me an accurate final answer, but I know what 2 times 4 is. So I think when I do this multiplication, my answer is going to be around 8. If I get something wildly different, like 800 or 8/10, then I know that I did something wrong. So estimation is a way for us to check our work. Before I actually show you how to multiply this, let's try one more estimating. Here we have 179 8300ths and 4/10. 179 8300ths, I'm looking at that tenths place. 8 is greater than 5/10. 8/10 is greater than 5/10, which would be halfway. So if I had 179 and 180, halfway would be 179 5/10. Since 8/10 is greater, we're going to round that up and say this is pretty close to 180. Now when I have 0 wholes, it makes for kind of an interesting problem. So if I were to say between 0 and 1, halfway between is 5/10. 4/10 is smaller than that, so we're going to round down. So it's pretty much 0. 180 times 0, my answer is going to be pretty close to 0. Now, another way to think about it when it's 0 and some number of tenths is I could round that up to about 5/10 and say, well, 5/10 is half. So I think that my answer will be close to half of 180, which is going to be 90. So that's a pretty big range, but I think my answer is going to be somewhere between 0 and 90. So you can see that both of those answers are a lot smaller than 179, and that makes sense because I'm not even saying I have one whole group of 179. I'm saying with this 4/10 that I have less than a whole group. So it makes sense that our answer, we're estimating and guessing that our answer is probably going to be less than, somewhere between 0 and 90. Now I'm going to show you how we actually multiply them, and we'll see if our guesses, our estimates, were correct. Alright, so when we are actually multiplying, we're going to set it up like a traditional multiplication problem. If this was 214 times 37, that's how I'd write it. So you notice that when we add and subtract decimals, we have to make sure that our decimal points line up on top of each other, and we're really careful about place value. That is not true here. In multiplication, I'm not concerned about my place value right now because I'm going to make sure that I have the correct place value at the very end. So you can almost pretend that these decimals don't exist right now. And we're just going to multiply as if these were whole numbers. So 7 times 4 is 28. 7 times 1 is 7, plus 2 is 9. 7 times 2 is 14. I need to put a holder, like a place marker there, because I'm starting in my tens place with this 3. That 3 is really 30. So I want to make sure that my answers start in the tens place as well. So 3 times 4 is 12. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6. I'm going to add both of those up. 4 and 4 is 8, plus 1 is 9, 6 plus 1 is 7. Okay. I have just some numbers. Whoa. 7,918 seems really not correct. So we're going to go back to our estimate. We thought that our answer is going to be somewhere around 8. Where could I put the decimal so that it would make an answer that's pretty close to 8? If I put it here, nope, that's 791. That's still really far away from 8. If I put it here, getting closer to 8, but 79 is still really far away. If I put it here, 7 and 9/10, that's very close to 8. Okay, that's an option. Let's just check one more. I could put it right here. 0 and 7, nope. That is not as close to 8 as 7 and 9/10 was. So just based on my estimation, I'm pretty sure this is going to be the answer. But let's double check. One way to double check is to say, well, look at my original 2 numbers, my factors that I was multiplying. 3 and 7/10. That has one number after the decimal point. 2 and 1400s. That has 2 numbers after my decimal point. I'm going to add those together. So I have 1, 2, 3 numbers after my decimal point. In my answer, I have 1, 2, 3 numbers after my decimal point, and that confirms to me that this is our answer. 7 and 918 thousandths. Let's do another one. So I'm going to line it up just like I was doing a whole number problem. So, oops. If you want to put the 0 in, you can. If you just want to put the 4 in, but keep that decimal point in front of it, you can do that too. I like to keep the 0 in just so that I make sure that I know what I'm doing. 4 times 3 is 12. 8 times 4 is 32, plus 1, that's a very bad one. 1 is 33. 4 times 9 is 36, plus 3 is 39. 4 times 7 is 28, plus 3 is 31. 4 times 1 is 4, plus 3 is 7. Now, 71,932 does not seem like our correct answer. So what am I going to do? Well, I'm going to go back to my estimate. I thought it needed to be somewhere bigger than 0 and smaller than 90. Well, let's see. If I put my decimal here, nope, that's bigger than 90. Erase. If I put my decimal here, 719, still bigger than 90. If I put my decimal here, 71, that's between 90 and 0. That's an option. 7 and 1,932 10,000ths, that's also an option. So I'm not going to know right away just based on my estimation. Because saying 0 and 7,100, oh, that's also an option. So I'm going to really need to rely on my strategy of counting decimal places to find my final answer. I have a couple that I know are untrue, and maybe if you had a multiple choice question that had all those different options, you could cross some of them off, but I need to count some decimal places. All right, here's my first decimal point. I got 1, 2 numbers after my decimal point. My other decimal point, that is the third, so 1 plus those 2 is 3. So I want to say I need to put my decimal point somewhere where there are 3 numbers, 1, 2, 3, after my decimal point. So my answer to this is 71,932. I mean, no, that's not right at all. 71 and 932 thousandths. Whew, gotta make sure you're pronouncing it correctly. Alright, let's try one last one all together. So, step 1, I'm going to estimate. 3 and 8 tenths, I'm going to round that up to 4. 7 and 2 tenths, I'm going to round that down to 7. 4 and 7, 4 times 7, I think that my final answer should be somewhere around 28. Now I'm going to multiply them. These do have the same place values, so don't get confused and just drop your decimal down here. That is not right. Forget about your decimals while you're multiplying. 2 times 8 is 16. 6, 7. Place value holder. 7 times 8 is 56. 21 plus 5 is 26. Add them together. So here are all my digits. I need to put my decimal somewhere that makes my answer close to 28. I think it's going to be right here. I'm going to check. I have 1 number after my decimal point, 2 numbers after my decimal point, 1, 2. Yep, there's my final answer.